Hello friends, today we will be continuing our lecture on indeterminacy of structures, and today we will be dealing with 3D structures. So previously in the last two class we have discussed about how to find out the indeterminacy of 2D structures. Now let us take an example of a 3D structure. So if we see here how many trees we can make out of these 3D structures, we can see we can make 4 trees by cutting it in 4 points. And as I've already told you that we should not cut it through the hinges, internal hinges. So let us cut it here, 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 and here. So what will be the 4 trees? So these are the 4 trees. Okay, now uh, here C will be how much? 4, because we have made 4 cuts. After that, let us try to find out r prime. R prime is equal to, in the case of 2D frame it was m minus 1, and in the case of 3D it is 3 into m minus 1. That is the difference, plus reactions. Okay, so for m minus 1, m we have to find out, this 3 into m minus 1 we have to do it for this ones and for this ones. So for this, what will be the 3 into m minus 1? It will be 3 into 2 minus 1, because this member and this member is connected, so m is 2. And for this part the m minus 1 will be how much? 3 into 3 minus 1. That means 1, 2, and 3. So 3 into 3 minus 1. So ultimately it will be how much? 3 into 2 minus 1 plus 3 into 3 minus 1 plus reactions. You see here, initially in 2D structures, what we did is, suppose this is a fixed point. So here 3 reactions for 2D, if we consider 2D case, and for hinge it was 2 reaction, and for roller it was just 1 reaction. This is for 2D. So 3 reactions, 2 reactions, and 1 reaction. But here what we are getting here for 3D, the fixed will give 6 reactions. Hinge will give how many? See here, fixed will give reactions in 3 directions. Okay, so this and in Z, somewhere in Z, then mx, then like my in some other direction, mz. So like ultimately 6 reactions are there. In hinge we get what? 3, xyz, so hinge 3. So if we have to make a hinge into a roller, how many we should, if we want to make a hinge, this hinge we have to transform it to a fixed. How many we have to add? We have to add plus 3, because in a fixed there is 6 reactions in 3D. Okay, so ultimately how many we have to add? You see here we don't have to add anything because it is 0. It is fixed. Here we don't have to add anything, but here we have to add plus 3 because hinge is giving 3 reactions here in 3D, and we have to add plus 3, and here also hinge is giving 3 reactions, so we have to get plus 3. So ultimately plus 3 plus 3. So how much is r prime? It will be 3 plus 6 plus 3 plus 3, which is equal to 15. So ultimately what is the value of degree of static indeterminacy? It is equal to 3 into how much? 4 cuts minus r prime, which is equal to what? 15. So it will be how much? Sorry, this is for degree of static indeterminacy, it is 6 into cuts minus r prime. That means ds is equal to 6c minus r prime. So it will be 6 into 4 minus 15. This is equal to 9. So that is how we calculate the total indeterminacy of a 3D structure. Now, after this, let us go to beams. See, in this classes, we'll be strictly restricting ourselves to the preparation of SSC JE 2019, and we will not study any unnecessary topics which have no probability of uh, coming in the examinations. So we'll be studying those things which are enough for clearing the examination with flying colors. So now let us go to the calculation of indeterminacy of beams. So if suppose a beam is given to us like this, one fixed and two roller. Now what we have to do is our aim is to make it to convert the beam to a cantilever. So how will we convert it to a cantilever? Suppose this is the cantilever. So we have to use this formula. Reactions removed minus restraints added. So how will you do it? You see here, this fixed is giving three reactions. This roller is giving one, this roller is giving one. So in order to convert it to a cantilever, how many reactions do we have to remove? This one, this one. So two reactions we have to remove. Okay. Then restraints added. Restraints is related to the support. So see, this is a fixed support, this is also a fixed support. Do we have to add any more restraint? This is already having three restraints. Actually, these are this three for the fixed support. These three parts reactions are called as restraints. So these restraints we don't have to add anything else because this is already fixed. So we have to add zero restraints. So 0. So ultimately this is 2. Now if we consider this one, suppose this one, this hinge is giving two reaction, roller is giving one, one and one. If we have to convert it to a cantilever, how many reactions do we have to remove at first? This one, this one, this one. So ultimately it is three reactions removed, minus how many restraint we have to add in this hinge. In this hinge, to make it to a cantilever, we have to add one restraint. So ultimately minus 1. So this becomes 2. So this is the way of making like the beam into a cantilever, and finally finding out the static indeterminacy by using this procedure. Now you see, you can convert. It's not like for the cantilever, for this cantilever the fixed support should be considered at the left end. It's not like that. We can consider it in the right end also. I can just give you one example. So if we consider the initial problem itself, this was the initial problem. So let us convert it into a cantilever like this. Okay, it means we are not considering the cantilever fixed support at this end, we are considering it here. This also gives us the same answer. You see how here you see this is giving three reactions, this is giving one, this is giving one. Now we have to remove this part, isn't it? Because this part is open. So ultimately three reactions we have to remove. Again here also we have to remove one reaction, that means plus one. Total reaction we have to remove is 4, which is equal to reactions removed. Now here this roller, if we want to convert it into a fixed support, how many restraints we have to add? This is already, there is already one restraint, so we have to add 1 and 2, so plus 2. So minus restraints added will be 2. So ultimately it will be how much? ds equal to reactions removed will be 4 minus restraints added will be 2, so it is equal to 2. So you see, you can convert it into the cantilever from all the sides. Either you can convert any beam to a cantilever like this, or to a cantilever like this. This will not affect your answer. Your answer will be same. So thank you very much. And in the next lecture we'll be like finishing our indeterminacy part. We'll be completing it with some more problems of degree of static indeterminacy, and then we will be going to kinematic indeterminacy. Thank you.